Alright gang, Stat 1150. The purpose of this video is to follow up on the central limit theorem. I know the previous video probably drove some of you insane because it dealt with some theory. Sometimes in learning things it's easier to go from a specific example to a generalization, and not as much a generalization to specific examples. And that's kind of what I'm going to attempt to do here. I'm going to look at an example and show you how all this unfolds with real numbers, with real data. So first thing I want to do is let's just revisit the central limit theorem. You begin with a population where the mean and the standard deviation is known. You choose your sample size, and if that sample size is greater than or equal to 2 and you have a normal distribution, then you proceed. If that sample size is bigger than 25 or greater than or equal to 25, then you proceed. The next thing you do is the theory part. You start taking out samples. So we choose n equal whatever this number is up here, and we would create the first sample mean. Choose however many again. Choose the second sample mean, whatever this is up here. If this is 12, choose 12 people, calculate their sample mean. If it's 12, choose 12 more, calculate their sample mean. Do it a third time. And do this forever. Central limit theorem says that this distribution of sample mean will be normally distributed with the mean equal to the mean we started with back here, and a standard deviation equal to sigma divided by the square root of n. I want to demonstrate this or illustrate it on StatCrunch. Okay? So I'm going to go to StatCrunch and get rid of previous information. And what I want to do is I want to create some new data. So I want to create some samples, and you know what? I don't want to do it this way. I want to do it another way. Something just hit me. I want to go to simulate, and I will go from a normal distribution. And what I want the rows to represent is the number of people, all right? Number of samples taken each time. So that's going to be my n that I start out with. So I'm going to let this be 30. And my columns are going to be the number of times I take the samples of 30. Now in the illustration I've given you before, that's forever, but I can't do forever, so I'm going to do just a really big number, and I'm just going to go out to 250 columns. I want to draw of a mean of 100 and a standard deviation of 15. All right, and I want to open in a new data table. So I'm going to compute. It's going to take a while because it's got a lot of stuff to do. Well, I didn't know it was going to take this long, but it did. So here's what I have first of all. My first column represents the numbers, well, it represents sample number 1. And what I could do is I could add all these numbers up, which I'm going to do in a minute, and get x bar 1. This is my second sample right here. I can add all these numbers up and get x bar 2. I can add all these numbers up and get x bar 3. and I can go all the way out to the right and see how many samples I've taken. Now, typically, in theory, you do this forever, but I can't do it forever. I have to just choose a large number and do it 250 times. Now, the next thing I want to do is I want to come in with a summary stat, and for my columns, I want to select them all. All 250 of them. And I want to build in, and let's just call it the means. And all I really care about are the means, okay? And I want to compute. Where? Percentiles, other statistics. My bad. I shouldn't have done this where, because I don't have anything set by that. Okay. So I want to store in a data table. So I'm going to compute. So now if I come way over here to the right, I can see that my first sample had a mean of 99.83. My second sample had a mean of 94.99. My third sample had a mean of 100.61. I promise you I won't go very far. Can you imagine if it went all the way down to 250? So I've created these sample means. So if I come back over here, and I want to do a split screen with you here so it kind of makes sense. Or I hope it makes sense. Maybe it won't. All right. So what was my sample size? Well, first of all, my mean was 100. My standard deviation was 15. My sample size was, as you can see over here, my sample size was 30. And I wasn't able to do this forever, but I was able to do it 250 times. It'd been much better to do it 2,000 or 20,000 or do it forever. But you saw how long it took me to get 250. I'm afraid I'd blow my computer up if I went too much. Now, the first sample mean was found over there, and I'm going to do it with the mouse. You can see it was right here. It was 99.83. The second sample mean was 94.99. The third sample mean was 100.61. And I had 250 of these, which I'm not going to write. So this column that I have in StatCrunch titled mean, that's my distribution of sample means. Now the central limit theorem tells us what? That these things will form a normal distribution. Well, we can't get it per se, but what I can do is I can look at a histogram of the means and show you that I get something that is almost perfectly bell-shaped and symmetric. Now, it's going to be better if I get a larger sample size. If I was to go out instead of 250, go out to 500 or 5,000, I would get just a more and more perfectly bell-shaped and symmetric distribution. But most importantly, what I know over here, the mean of these sample means should be very, very, very close to 100. Well, guys, I can do that. Let's go to Stat. Let's go to Columns. And I want to find the mean of the means. Well, 100.037. Pretty close. Now you might be saying, yeah, Dr. Darbro, that's not exactly 100. It's not. I would have to do this forever for it to become exactly 100. I just did it 250 times. 250 is a pretty big number to us, isn't it? In relation to forever, 250 is not really that large, is it? But it's pretty close. Now, the standard deviation of these means is 2.72. Now, is that close to what we should have got? Well, what we should have got is sigma, which is 15, over the square root of the sample size, which is 30, not bad, 2.74, so we were off a little bit. But again, we're off a little bit because 250 is a long way from forever. It's a big number. It's big enough to get us pretty close. But again, if I went 500, this and this would be closer. If I went 750, this and this would be closer. If I went 5,000, it would be closer and closer. I'd blow up my computer, but it would be closer and closer. So, guys, I hope that makes the central limit theorem make a little bit more sense. So, you know, if we were gonna look at from this demonstration the probability that a sample mean was you know, greater than 102, for example, what we could go through here and we could say, well, there's 1, there's 2. In fact, I wonder if I can group from low to high. I wonder how you do that. Shoot, I know there's a way you can do it, but let me see. You know, there's a way to arrange. Well, sequence maybe. Well, anyway, I could arrange this from low to high, and I can go through here and count the ones that are greater than 102. Take that count divided by 250, I would get the probability. That's an empirical probability. The theoretical probability, I'd need to do more than 250. I'd need to do it forever. All right, guys, that's all I got. Take care.